This is a problem from Chapter 6 out of Practice Problem 6.1. It's problem number 10. I want to go through this one because I disagree with the answer that's in the back of the book. I think it's just kind of a misunderstanding. I'm going to show you a few different ways to do this problem. So they're saying that this active ingredient, cefotaxime, comes in 10 grams per 100 milliliter concentration. That's what's on the shelf. The question is, how much diluent must be added in order to end up with a concentration of 50 milligrams per milliliter? And right off the bat, I want to point out to you the thing that I'm having to pay attention to is that the stuff that's on the shelf is in grams. The concentration that I want to end up with is in milligrams, so I'm going to have to make a change there. So the first way I want to do this is using the quantity concentration method. No matter which method that you're going to use, you're going to, well, except for the proportion, you're going to need to change. You're going to change these concentrations. You're going to have to figure out what the strength is. So for the one that's off the shelf, which is 10 to a 100, that's really easy to find because the denominator is already 100. So the percent strength on there is just 10%. When you look at the other one, the 50 milligram per milliliter, I'm going to first change that over to grams, which I did right here. And so it's I swung the decimal 3 places to the left. I get 0.05 grams for 1 milliliter. And then I want to change that over to a percent. So I changed it over to something over 100, multiply top and bottom by 100, you get 5. And so the concentration, the percent strength for the second one is 5%. So now I'm going to set up this equation: strength plus times quantity plus strength times quantity is equal to strength times quantity. This is the off-the-shelf stuff. This is the diluent. This is the ending concentration. So I'm saying let X equal the amount of diluent that you're going to be adding to this. It could be sterile water or who knows what they're adding. If that's the case, if you're adding some quantity to this, then the ending quantity has to be whatever you're adding plus whatever you started with. And what I'm saying is that the quantity at the end is the 100 milliliters that comes from off the shelf plus the amount of diluent that you're going to be adding. And that's why I have 100 plus X associated with the total quantity over here. So I've got 10% times 100 is equal to 0% because it's a 0% strength for the diluent, and for the ending one, it's 5% times that 100 plus X. So I went ahead and changed each one of them to a decimal, that one to a decimal. I really don't have to do anything with this 0%, and then I changed the 5% to 0.05. This 0 times X goes down to 0, and 0.1 times 100 is equal to 10. So if you run that on your calculator, you're going to get 10. And if I multiply 0.05 times 100, I get 5, and 0.05 times X gives me this last part. Then I went ahead and I subtracted 5 from both sides, which makes my 10 now become a 5. And then I divided both sides by 0.05, and I end up with X is equal to 100 milliliters. That's how much has to be added in order to get the final strength that they're asking you for, which is 5%. Now the book says the answer is 200 milliliters. That's not true. You're not going to add 200 milliliters. What you're going to do is end up with 200 milliliters. 100 that you started with for off the shelf, and 100 that you're adding as the diluent. The second way I want to do this, and in this particular case, and you might find this surprising for me to say this, but is the alligation method. And this, because of the numbers, only because of the numbers, is really, really easy. So this is what I'm starting with. You're still going to have to go through this percent stuff. You're still going to have to figure out the percent strengths. So even though it looks really, really short, there's a little bit of work that we did up on top that you're going to have to do down here. So you're starting with something on the shelf that's 10%, you're adding a 0%, you want a 5%, you subtract these two, get 5, you subtract these two, get 5. So it's 5 parts to 5 parts, which means it reduces 1 part to 1 part. Well, and then the total is 2 parts. Well, let's think about it. If it's 1 part of the stuff off the shelf and 1 part diluent, and you've got 100 milliliters off the shelf, then you must be adding 100 milliliters of the dilutants. So you can do the answer with no math. And then the total would, of course, be those two added together, 200 milliliters. The third method, which you probably would not think to go for, is to set up a ratio. And here's what I started with off the shelf in grams, and this is the one that I had to change to grams. And what I did was, I said let X be what you're adding, the diluent, to what is on the shelf. I'm adding something to this 100 milliliters. I still have 10 grams of the hot stuff in there. But this X, adding X to it, is watering this down, and it's watering it down to this desired level, 0.05 grams per one liter. I do cross multiplication, and the math is basically the same as what you saw up here. I still get an answer of hope that's not going to show. Still get an answer of 100 milliliters. So I hope that helps.